In this video, I'll show how to use PowerPoint to create Escher designs using rotation around a vertex. Now there's a bit more to doing rotation designs, but we'll start with the same table for putting in our designs and writing in our descriptions. I'll use a square for this. It needs to be a shape that has adjacent sides that are equal in length and angles that are a factor of 360 degrees. Because I'm inside the table, using the shift button to scale my square won't work, but I can draw the shape and then use these settings at the top here when I click shape format so that the height and width are the same. Now, removing the fill and adding the vertices again, I'll be finished on my first cell and I can copy this to the next one. As before, in step 2, I can just alter any side. I'll alter side DA again. And so using the curve tool, click on one vertex, make a few other points for the curve to bend around, and then double click on the last vertex. Now when I go to step 3, I'm still going to copy and paste, but now I need to rotate this alteration. I can use the manual rotation, or I can open the shape format options, click on the format pane, and then select the size tab so that I can enter in the rotation exactly. Now what I have to be careful of here is that the placement of the alteration corresponds with what would happen if we were fixing the line at the vertex and rotating it there. So if I alter D to A, selecting 270 degrees would be what I'd do if the point of rotation is A and the line is going to sit on AB. But if I do 90 degrees, then that rotated segment should sit on DC and would be equivalent to rotating around D. Now again, we can remove some of the original lines so that it looks a little bit neater. And we should write in a description of what we've done. So again, we're just starting with our square, ABCD. And then at step 2, we're altering line AD or DA. And then at step 3, thinking not about what we've done in PowerPoint, but what's happening in terms of the Escher method. We've rotated around D, and this line has rotated clockwise 90 degrees. So think of it like a clock with the center at D, and these squiggly hands have gone from 3 p.m. to 6 p.m., which is a 90-degree turn. You can use the same ideas now to alter the other two sides, and as with the translation method, we can use this technique if we want to get some more color or detail into our final design. Now when it comes to rotating our shape, we need to remember the points of rotation. These should be the same points of rotation when we copy and paste the shape and fit our shapes together. So the AD sides will fit into CD sides, and the AB sides will fit into BC sides, which we describe as rotations of 90 degrees clockwise around D or 90 degrees clockwise around B. So that's using a square as the basis for an Escher design, applying the method of altering adjacent sides by rotation around a vertex. We can also apply this method to two sides of a triangle, so we'll start with that in the next video, and then we'll use the midpoint alteration on the final side to demonstrate the third method.